Alright, this is lecture number 6, Physics 112, and I'm going to do an example, and it's not from the book, so I just made it up so that you will understand the idea more. So let's suppose I have an XY coordinate system here, and I have a positive charge, let's say 1, 2, 3, then I have a positive charge here, and Q is, just call it 1 coulomb to make things easy. 1, 2, 3. So another one here is Q is equal to 1 coulomb. They are positive charges. Then I want to find the electric field 1, 2, 3, 4. So at this point, electric field at this point. Okay? So first of all, I have to know that I have two charges, so there will be two electric fields acting at this point. And what I want to know is the net electric field at this point. So if it is only one, then I just use KQ by R squared and I'm done. But I need to find two electric fields, right? So let's think about this. Coming from this positive charge, we know that electric field, direction of electric field is away from the charge. And for this one, the direction of the electric field will also be away from the charge. Alright? Because this is 3, this is, now let me put, this is 3 meters. This is 3 meters. I'm using it so that it's easy. And this is 4 meters. Okay? So then from Pythagorean theorem, this is 3, this is 4. So 3 squared plus 4 squared is, 3 squared is 9, 4 squared is 16. So this distance is actually 3 squared plus 9, 4 squared, square root will be 5, right? Because that's 25. And take square root, you get 5. So this distance D is equal to 5. Now I know how to find these guys. And electric field, let's call it E1. And this is electric field E2. So how do I find E1? Well, E1 is in this direction. The magnitude of E1 can be simply found by KQ by R squared. And K is what? 8.89 times 10 to the power 9 Newton meter square per coulomb squared. And Q is 1 coulomb, so it's easy. The distance between the charge and the point is D. This is also D because it's the same 3, 4 triangle. So D is, we know that's 5 meters. Okay, so that's 5 meter squared. So 5 squared. Alright? So what do I get for E1? The magnitude of E1 is equal to 8.89 times 10 to the power 9 Newton meter square per coulomb squared, that's from K, times 1 coulomb, that's for the charge Q, that's Q 1 coulomb, divided by R squared, which is D squared, which is 5 squared, so that will be 25 meters squared. So you see that meter square cancel out. Coulomb and coulomb square, one of the coulomb cancel out, so I still have 1 coulomb left. So the unit will be Newton per coulomb. So my answer is 8.89 divided by 25 times 10 to the power 9 Newton per Coulomb. That's magnitude of E1, the electric field E at this point coming from charge number 1. So what about coming from charge number 2? From charge number 2 it will be the same, because E2, magnitude of E2 is also K Q by R square. Again, Q is 1 Coulomb, the same. R is still 5, so this is distance D is 5, this distance D is 5, so the distance R is 5, and K is 8.89 times 10 to the power 9, and Q is 1 Coulomb divided by 25 meters square. The answer is Newton per Coulomb, right? Okay, now I get that. Now if I want a little bit more number, then 8.89 by 25, let me do that. 8.89 divided by 25 is equal to 0.3556. So it's equal to 0.3556. So that's 3.356 times 10 to the power 9 newtons per Coulomb. And so this will also be 0.356 times 10 to the power 9 newtons per Coulomb. Alright, so I get E1 and E2. Now it's not done yet. Now I need to find the net electric field. In order to find the net electric field, or the resultant electric field, I have to add these two vectors. So let me redraw the picture now. So I will move my coordinate origin to this point. I can do that, right? Or I can just do the vector decomposition here. So not to confuse you, I'm going to do it at this point. So let me do this. So this is my E1 and that's my E1, right? And they have the same number, same magnitude. And what about the angle? Angle theta I need to know. So angle theta is the y component divided by x component, and I can look at that. Angle theta, tangent theta is y component divided by x component, or from this triangle, if I look at this as angle theta, then this will be angle theta. This also be angle theta, so this will be angle theta. So opposite divided by adjacent, 3 by 4, that will be tangent theta. So tangent theta is equal to 3 by 4. That tells you that theta is equal to tangent inverse 0.75, because 3 by 4 is 0.75, and theta is equal to, let me do that, tangent inverse, so shift tangent and 0.75, close bracket. That will give me 36.87. Actually 87. So 36.87, that's good enough. 36.87 degrees. Alright? So now I have to decompose E1 and E2. Why? Because E1 and E2, they are not x nor y axis. So I have to decompose them. So when I decompose this guy, then the x component will be here. That's E1x. And then also E2x in the same direction. So E2x. So these guys are going to add up. What about E1y? E1y will be in this direction. And this is E2y. And E2y. This is E1y. Will be in that direction. Okay? Now I need to find these components E1x, E2x, E1y, and E2y. Now we see that E1y and E2y are in opposite direction, and we'll see that they have the same magnitude, so they will cancel out. Why is that? Well, E1y is equal to E1y is equal to E1 sine theta. E1 is, I know whatever E1 is, but let me see sine theta. So that sine, the magnitude sine theta is sine 36.87 degrees. So if I put it in the calculator, E1, I found E1 is 0.356 times 10 to the power 9. So 0.356 times sine 36.87 degrees, and that is 0.2136 times 10 to the power 9 newtons per coulomb. And what about E2y? E2y also is the same number. Why? E2y is E2 sine 36.87 degrees, because E2y also has, this also is angle theta, so E2y is also E2 sine 36.87 degrees. And it'll be also E1 and E2, both of them has the same number, 0.356 times 10 to the power 9, 0.356 times 10 to the power 9. So this is also 0.2136 times 10 to the power 9 newtons per coulomb. But E1y is pointing up, E2y is pointing down, so they will cancel out each other, so there is no y component. But E1x and E2x, they are in the same direction, and they'll be adding up. So let's see that. E1x is equal to cosine 36.87, and E1 is 0.356 times 10 to the power 9, and cosine 36.87. So cosine 36.87 is 0.8. That'll give you 0.8 times 0.356. That'll give you 0.288, 0.288 times 10 to the power 9 newtons per coulomb, or you can write it as 2.88 times 10 to the power 10 newtons per coulomb. And similarly E2 x is equal to 2.88 times 10 to the power 10 newtons per coulomb. So the net result is in the positive x direction, and what we will get is that E1x plus E2x, the magnitude of resultant vector E resultant, will be 2.88 times 10 to the power 10 plus 2.88 times 10 to the power 10 newtons per coulomb. So there will be 2.88 times 2, 2.88 times 2 is equal to 5.76 times 10 to the power 10 newtons per coulomb. So that will be our net result. And the direction, if you are wondering, this is positive charge, this is positive charge. We are looking at it here, and the y component cancels, so the net electric field will be pointing in that direction. This will be the E resultant. Net electric field will be in that direction because the y components have cancelled out. Okay.